All right. So the assignment, I'm just going to do it right away, and then I will provide a link for all of you too. So let me share my screen quickly as possible, and then I can simply pick up where we are. All right. So this was the assignment that I gave earlier because today is a holiday, and I thought that no, we shouldn't be resting at home for free. I'm actually talking about those who follow me for my tutorials. What is it? They are those I am referring to. And then, all right. So I'm just going to do that right away, and then I'll get back to all of us. So this was the assignment that all of us needed to to look at. First of all, we needed to create six different vectors of 20 professionals, and then their salaries, their weight, their height, their age, their travel distance to their workplaces. We create these six different vectors, and we use the vectors to create a data frame. And of course, we can also add a column to there. And the column we are going to add is to calculate the BMI of all of them and add it as a column. Yeah. So we can easily correspond. And of course, we also needed to use the same data to what is it? To create a matrix. And of course, I use the same data to create an array, which will have column names, row names, and of course the names of the arrays. And then the last one, we needed to also see whether there is a relationship. We needed to do a correlational analysis of all the variables. Okay, so let's kickstart. This is my arrow. I have done it already. So I'm just going to, take some or most of these things out. What I'm now going to do is just to explain them one after the other. So the first question, if you're watching, we needed to just make sure that if you have your R Studio, then the first one was to create your vectors. So you see that I created the vectors of professionals. When you are naming your variables, they should make sense. This is very important in all programming. Name variables that are very, very significant, or that you know tells the name. But why I want us to do this, I actually didn't give any value. I didn't say these are the salaries and whatsoever. So I wanted us to see how all of us can use some of the inbuilt functions in R. And so uh, we use the combine function in vectors to create the vectors of the professionals, police, teachers, parliamentarians, nurses, and all of them as we have it here. That's what I did. And quickly, you can see it here. So I have just, if I run it, it picks straight up. And then to another variable we needed to create is salary. And I use this function, which we call sorts or sample.int. So that's where sampling integers. And so we are sampling integers of up to 550,000. Sorry, 5,000. And then we want to get 20 variables within 5,000. So it's like random numbers, which are integers. And so we just want to sort. So we are going to pick some numbers or some figures from within 5,000, and there should just be 20 of them. That's what this means. Sort, and then that's the function you have to use. So I use that one to create the salaries, and we just run that. And the height, I decided to use another function called run if. The run if, it gives you the syntax is you follow it by the number of variables you want to create, give a minimum and then the maximum numbers. So I want to create 20 variables of a minimum value of 2 and a maximum of 5. So I will simply create that for you. But I added this floor here because when you are using run if, it comes with decimals. It comes as floating numbers. So you need to run it up to, to single digits. So that's why I added the floor. I could have added ceiling like I did it in weights. Any of them, floor means run down, and then ceiling means you have to run it up. Yeah, okay. That's what that means. So the age, I decided to use sample. So I am sampling from 17 to 61. That is simple. So I have a range of 17 to 61, and I'm sampling just 20 of them there. Just like the way we do sampling in ordinary statistics. You have a population and you are just picking a sample. So when you say sample, you give a range and you say, how many do you want to sample? I want to just sample 20 of them from from the range I have given. So I'm expecting that. But when you give a sample, the limits are always not inclusive. So it means 17 will not be there, 61 will not be there. So I'm sampling within from 18 to 60. So I do that for ages. I was expecting that all workers in Ghana, you begin work at 18 years, you retire at 60. So that's the permissible. So that's why I put it there. So the travel distance, I was thinking that um, almost everybody, what is it, average distance of travel is 20, maybe 20 kilometers. Yeah, I think so. So I decided to use another function in R, which we call R norm. In creating random numbers in R, there are several of them that you can use. You can actually use those I have mentioned on top here. There are quite a number of them you can use. The run if, the short sampling, what is it? All of them, the sorting, you can use any of them to actually create your random numbers. But apart from that, you can also use probability distribution to also create any random numbers. And you can see that I have used a normal probability distribution. When it comes to probability distribution, we have quite a number of them. We have Poisson, we have binomial distribution, we have normal distribution. Usually, I use the normal distribution just to make sure that I have what my figures within range. And doing that, the syntax is rnorm, and you have 20. It means I'm creating 20 variables, and I'm saying that the average, you just give it an average. So it means the average travel distance is 20. And then the deviation means how much does the average differ, both left and right. So the deviation, you give the standard deviation, which is 5. That's how much the mean depart from the reality. So we create that, and then when we do that, we can simply run, and then we have that also. So I have finished creating the 6 variables. So now I have my profession, salary, height, weight, age, travel distance, and that's all. So the next thing is to create my data frame, which was the next question. To create a data frame, I just said the data frame, I titled the variable prof underscore data. So you just simply just say data.frame. That's also a function in R that you use in creating data frames. I keep saying in R, the function you are using is what R uses to know what you are looking for. So in data frame, this is the syntax. You bring the function and open the bracket, type in all that you want it to form your data frame. The order of which you have typed them here, that's how they are going to appear. So the first column will be profession, second salary, in that order. So I run this, my data frame is being built. So if I come here, I can just print out the data frame, and when I pull up my console, you can see the data frame has been created, which is here quite beautifully. Yeah, I know. So the data frame has been created. So the next question was for us to at least also add a column. We're supposed to add a column of BMI to the data frame. But that question, I expected that before you can add a column of BMI, you need to calculate the BMI first. And to calculate the BMI, this is the formula. BMI is equal to a kilogram of the person divided by his height squared. So we have height already given in the data set. So we needed to come out with the algorithm. And around here, what I'm going to highlight is actually where the formula is. Usually, if you have a data frame like this is the data frame from where we want to actually calculate our BMI. If you add $sign to it, it will bring out all the columns over there. So we have a column of weight, and we want to divide it by height squared. So what we do is we simply come, and then we have the data frame here, and then we are telling R that go into the data frame and bring out this particular column. Now divide that particular column by this particular column of the data set, the height column of the data set, times the height column of that same data head, because height times height will give you height squared, and it's the same thing. But in R, there's a syntax. If you are dividing something like this, if you are combining different mathematical operations, the best way is to make sure that you have them in parentheses, so that if not, arrow will simply divide it before it will go ahead to start the multiplication, which will not give you the. So that's why I put them in braces. So it will compute those in braces first before it will start the division. And when you so if I run the whole thing, I am going to get my BMI. BMI has been calculated, but it's going to come with a lot of decimal points. So that's why I decided to put a round up. So you can round up the figures, and then I'm rounding up the whole of what is in the brackets here, and I'm rounding to decimal place 1. That is why you have the 1 here. And so when I do that and I run the sorry, I've run an empty space. If I run that, so the BMI has been created. In this case, now if I print the BMI, you will notice that you won't have, you see that they are now 1 decimal places. So the BMI has been created. Now, what is next is to add the BMI as a column to the data frame already. So this was our data frame that we have built, which is professors underscore data. So, and we want to add a column to it. So this is the column we want to add, BMI. But we have already calculated that BMI. So we create the column name BMI. Then we direct the data of the BMI that we have calculated to it. So it will simply come and occupy that particular column. That's how we add a column to a data frame. And when I do that, if I run it now, you will see, and I print the data frame again, you will now see that instead of 6 columns, there will be 7 columns now. So let me roll up. You can see that we now have a column here, which is BMI, and the BMI has been added. So that question too has also been answered. So the next one we're supposed to do was to, We're supposed to create a data of using the 3 vectors that we have created already. So that was a question 4. So what we're supposed to do, we have already created a vector of salary, a vector of weight, and then age. So what we can do is just to create this, come up with this variable called data. Don't mind the spelling. Variables, you can spell them the way you want. The only thing is that you can't have 2 variables at the same time. They will always be replacing each other, depending on the one you run first. It will always take precedence. So that's why I spell it this way, because I've already got data. In my computer, so I don't want to conflict it. So that's why I spell. So we come and use the concatenate sign to combine all of them and then pack them into this particular data. So the data has been built. First, that's what you need to do. We build the data, and then we can now use that data to construct our matrix. So when we come, this is our matrix here. The function is simply, you have your matrix. I mean, the syntax is the first value is the data set, followed by the number of rows, number of columns, and col and row means. And then you add this, which we normally say either true or false. What is it? When you put here, if I close here and then I hashtag the rest like this, I could just hashtag this one as well. So if I do this and I just run it, I have built my matrix. All right, I have simply built my matrix here. So if I print it, you can see my matrix there. So the matrix has been built, and that's how we build a matrix. Now, but if I want the matrix to have names, like the rows will have their own names, the columns have their own names, the simple thing to do is to simply create other vectors. And that's where I created those vectors down here. I think I should have created them on top. I realized it later on. So I created them down here. So I have row names, and then I have to give them, it's also a vector. So all the rows, how many are in the rows? The rows are 10. So I have to create 10 names and then pack all of them into this variable called row names, array names. Then I have to also create column names as a vector. So how many columns are there? 6. So I have to create 6 different column names using the vector function and pack all of them to the C names. And that becomes my column names. So when I do that, and then I come here, I can simply, so I now come, I remove this hashtag, and then when I do that, so I think I need to close up this space. Now, when I now run the matrix again, and I decide to print the matrix again, you will notice that that one will now have column names and row names. Have a look at it. You see that the first one here, we didn't have that. But the second one, you now see that we have row names and column names. This is very important. For instance, when you are doing correlational analysis, you will know which one you are analyzing. That's what we always put to know, okay, what is the relationship between weight and then nurses or whatsoever. And that helps a lot. So that was it about. So we needed the fifth question was to simply create an array, and then the array too we needed to, and then this is the simplest syntax for array. You always have the data, and then you use the vector or the combine function to create the number of rows and columns and the number of arrays you wanted to print. Array is just a matrix that has been repeated a certain number of times. So it's not too different. So here we have an array of 10 rows, 6 columns, and the arrays are 6 different types. So let's say you are having department 1, department 2, department 3, and you want to put them as an array. That's how we always represent them. So if I run this, you see that it's also, I have built the array. If I print the array, you're going to see that we're going to have 6 different arrays. So let me pull this up, and you notice that you see that the arrays are, you see that it's just the same matrix, but has been repeated 6 times. That's the difference between array and matrix. And then when we have done that, but we needed to create the array with their row names, column names, and each of the arrays should have its own name. So to do that, you need to create the row names first as a vector, create the column name first, and create the array names too. And that's why I named that one, what is it, matrix names. I think I should have done it array names. I can just change that. I can just put it array names, then that will make much more sense. And come here, change it to same way, ARR names. And so in that case, just, oh, sorry about that. So when I come here, I simply just have to run this again. And then when you now come here, so you have your array, your data is here. Then you have specified your rows, your columns, and the number of arrays you want to print. Then you come to dimension names. The dimension names is the row names, followed by the column name, followed by the array names. So and which vectors have already been created on top here. So now that's the vectors I've just put them here. And you use the list function to do that. In this case, you're not using the combine function, you use list function to do that. But let me remind you that in order of precedence, if here you put rows first, here it must be rows first. And you must know the number of rows that you have. If the rows are 10, you must give 10 names. If the columns are 6, you must give 6 names. And the order too must also matter. If not, it will not run. So when we do that, and now we come to print the array here, obviously you will see that all the arrays will now have their names, their row names. You see that the first array is called department 1, and their rows and their whatsoever is there in all of them. We can see that they are all there. So that was the last question. And then the one I added was the correlational analysis, which I'll quickly do that right away. Correlational analysis, you now want to find out what are all the variables we have created: weight, salary, distance to your workplace, your age, whatsoever. Is there any correlation between your age and your salary, your profession and your distance of whatsoever? So in that kind of analysis, this was just an example. But when you've picked up your data and then you want to find out whether there's a relationship, whether if somebody distance between where he stays and where he works reduces, does it increase his productivity? You can use correlation analysis to find out. So I decided to do that. And to do that, you need to load a package in R called ggcoreplot. So what we do is, to load a package means to library it. By that time, you would have installed the package already. I haven't reached that portion. There's a day I will do a tutorial on how to install packages from the CRAN, how to install it from package materials here. If you've been following my tutorials, when you come to the right bottom, you see that there's an install here. You see packages, you say install. Then you simply type the package you want to install. Come and click install. It's going to install everything. And after that, you have to library it. Library means load it into the R environment so that it will work. I explained earlier why we do that. So when you have done that, and then the package is there, we now use that particular package to actually generate our correlational figures. So to do that, this is the function you call, and then you put the matrix. And let me say this: in generating your correlation, the kind of data you use is matrix. So which means if you are having your data, it was in whatever form. If you want to actually have a correlation analysis, change that particular data into matrix data, and you now can run your correlation on it, and it will give you whatever that you are looking for. So to do that, we have core, and then, but when we run the core with the matrix data, it's going to give us the correlation with so many decimal points. So that's why I also run it up to decimal place 1. And let me run it, and then you see. Then you notice that now, if I come to print, the correlation of the professions, you can see that these are the correlations. You can see the correlations are here. Yeah. So if you are somebody who is good at figures, you can just copy this one and put it on your report, and then say this is the correlation that we have noticed. When you have 1, it is a strong correlation. If you have a negative 1, it's also a strong correlation, but negative. We know how to interpret correlation, but this is always too difficult. So what we normally do is to just to generate a map, or a plot. The plot gives you a clear indication as to how what the correlation works or it looks like. So to do that, you just use the GG core plots, and then you can run it with the correlation that you have already obtained. This is the correlation that you have already obtained. So you plot that particular correlation, and when I do that, it generates this particular plot for me. I can just zoom it for us to see. So this is the plot it's going to generate, and we can see the correlation. So we have the professions here, we have salary, we have height, we have and we have weight, we have age, and then we have the travel distance. We can compare that or what around here. So what are age and age? What is there a relationship between your height and your profession? But this plot is not too visible for us to be able to see the distinction. So I decided to add something we call method. Method, and then the method means the way you want the plot to come. When we get to data visualization, I will show you how we can actually generate very good plots. So you see that I've changed the method to circles. And so the size of the circle tells you how strong the correlation is and the density of the color. So you can see that 1 is a strong correlation, and you can see the color is very deep there. So coming down, the correlation is about 0.5 here, and where you have white, there is practically no correlation. So we have generated the plot. Now we can actually interpret this plot quite easy. For instance, if we compare profession to height, is there a relationship between profession and height? Well, yeah, there is. There is some semblance of profession. Is there a relationship between profession and salary? Yeah, perhaps there is some kind of relationship, strong relationship, because your kind of profession would determine your salary. If you are a garden person, a garden man, and somebody is a lecturer, I'm not too sure you're going to have the same salary. So you see that there's a strong correlation. Some places you see there's no, but your salary and your travel distance, is there any correlation? No. Look at it here. If you look at it here, there is no relationship between your salary and your travel distance. Whether you are traveling from far or near, it doesn't determine how much you collect. That's what the figures are saying. So let's look at your profession and your age. Your age does not actually have any impact, doesn't have much impact on your profession, even though there's some kind of relationship, perhaps. And then that's how we interpret it. And you can see that in general, we can say that it is positively sloping upwards. If I were to add a line to it, but that is when we get to data visualization in R. That's where we can add all the graphics for us to be able to see the pattern. This is not all. I could add other things to print the correlation strength and whatsoever. I could group the correlation and say that, okay, the strong ones are here, the weak ones are here, and this and this. All these things are things that we can easily do. So that's it. That was the assignment I gave as a holiday assignment. And I said, no, we shouldn't sit down home, not doing anything today, especially those of you who followed this, my basics to data science tutorial. That was the assignment we gave. And then, so if you have done it, just keep the data I will come back again and ask so many questions on this same data that we have built, and then we can use that. If you also know how to now build this kind of data, we have to build a very large data set. Then we can, in fact, realistic data set, and then we can use that. Perhaps we can actually request for a data set from, let's say, the Ghana Statistical Service, where we're looking at poverty kind of thing. And then let's do a correlational analysis ourselves. Any data at all we pick, we can actually do the correlational analysis. Now we know how to select to subset from a data frame. We know how to turn that data frame into a matrix, and we know how to now generate our correlational figures from there. We can actually do regression. We can do any kind of regressional analysis. It's a whole topic one day that we're going to be looking at. But this one just came suddenly, and I decided to just, it's not part of, we haven't reached there. From here, yesterday we did statement. I'll be going to for loop and while loop. After that, we'll go and look at how to import data into R. We'll look at installation before we go to look at data visualization. So thanks very much if you are watching, and God bless you. That has been your R tutorial for today. And if there's anything you don't understand, put it in the comment. Then what is it? And I will explain. It's always a pleasure. If you want, you can join our class. We have a WhatsApp group, which I put it on my Facebook page. You join every day, 7 to 8. We always have our class. So very soon it will be live, and then we'll be doing it. Thanks. Bye-bye. Yeah, hope you've learned something. Bye-bye. I'll see you.